Trigonometric identities. So to form a good base for solving trigonometric identities, we are doing a couple of questions which was preparing us to prove trigonometric identities. Okay. The question here is, use Pythagorean identity and state equivalent expression. Okay. So we have got cos square x. Here we have cot square x minus cosecant square x and tan square x. Now the question is, do you remember the Pythagorean identities? Okay, now let me show you how to remember them. First you should remember them, right? If you don't remember them, then how to get them? So it's very simple. You just make a right angle triangle, and let's say this is the right angle triangle, and in this triangle, let us say these are my sides x. Let me use O for opposite side, that's the angle x for me, A for adjacent side, and H for hypotenuse. Okay, so you know SOHCAHTOA, right? So we are using opposite, adjacent, and hypotenuse as the sides of our right triangle. Now here Pythagorean theorem is that A square plus O square equals to H square. Correct? If you divide by A, for example, then you get one identity. If you divide by O, you get another identity. If you divide by H, you get the third identity. And all these three identities are called Pythagorean identities. Okay, let me show you here. So first let's divide by A and see what do we get. I mean A square. Okay, A square, A square, and A square. Now A square over A square is 1, and opposite over adjacent is what? Opposite over adjacent is tan. You get 1 plus tan square x equals to H over A is secant x, right? The secant square x because it's H square over A square, right? So that's our first identity. The second one, what we will do is we'll divide by O. So I'm rewriting our equation A square plus O square equals to H square. Divide this time by opposite side square, O square, and O square. So A over O, A over O, do you see? Cotangent. So it is cot square x plus 1 is equals to H over O. It is reciprocal of sine. So it is cosecant square x. So that's the second identity. And let's derive another one. Another one is A square plus O square equals to H square. Now divide by H square. If you divide by H square, what do you get? So work it out. A over H. So A over H is cos square x, and O over H is sine square x, because it's a square I'm saying, and H over H is 1. So we get the third identity, okay, which is sine square x plus cos square x is 1, correct? So that is how. So let me write it here. So this identity is, so first I should write cos, right? So let me write cos square x plus sine square x equals to 1. So that is what you get from here, correct? Now let's look into the question once again. Use Pythagorean identity and state equivalent expressions. So cos square x. So from here, what can you write cos square x as? So we can write cos square x as 1 minus sine square x, right? So I can write this as equal to 1 minus sine square x, correct? But you should remember all these three identities, okay? It is a must to do trigonometric identities. Now second one is cot square x minus cosecant square x. So what is this equal to? We have cot square x plus 1 as cosecant square x. If I put it this side, cot square x minus cosecant square x becomes minus 1, right? So this is equal to minus 1, correct? How about tan square x? 1 plus tan square x is secant square x. Therefore tan square x is equal to secant square x minus 1. So I can write this as secant square x minus 1. Okay, so that's how we can write them in different forms. Okay, so remember these identities, they are very important to solve trigonometric identities. Thank you.